Yes, this is Anshu, and I'm gonna walk you through my implementation of MergeSort. So as you can see on the screen, there is this class which I've implemented over here, which has an array, which is essentially a vector structure, and then you have the second vector structure, which is a temporary array, and this is the one which is actually going to hold the temporary variables, or when we are actually going to copy the variables from the two arrays that we have. Temporary is actually going to hold the temporary variables at that point. Okay, so everything will be clear once I go through it. And then I have the merge function, which is a private function, as you can see, and it takes in the variable integer low, then the middle value and the higher value of the array. Then I have this function sort array, which is another function which is actually a recursive function. This one takes in the low value and then the higher integer value. And then I have declared these public functions, which include MergeSort, which is my constructor. And then I have the sort array v1 function, which is essentially the function that we will call to internally do a merge sort. And then we have the print array function, which will print the array which is stored in this array over here. Okay. And this constructor essentially, it takes a reference to my array that I'll be defining below in the main function, and it initializes the array structure, which is an integer array, and it initializes my temporary vector as well, which is again an array based on the size that I gave over here. Now as you go down, you can see there is the sort array v1 function, which is essentially what we will call from our main function, and this sort array v1 function calls sort array, which is a recursive function. Okay. And to sort array, we are going to pass the lower index number, which is the first value in my array, and the last value of my array. Okay, so array dot size minus 1, which gives me the last value of the array. Okay. In the sort array function, I'm checking if the low is less than high. Okay, and then I'm calculating the mid, which is the middle value, and then so our array can be even or it can be odd. So in both the cases, we'll actually get an integer value. So for example, if you had say 5, which is divided by 2, in that case you will get your mid value as 2. Okay, and if it was 6, it will be 3. Then I call my sort array function, which with the low index number and the middle index number. So essentially we are dividing the our array into two parts at this point, and so this function is going to be called recursively until we have this condition where low is greater than high. Okay, or low is equal to high. So that is the stopping condition that we have, and then I have the second sort array function, which essentially has mid plus 1, which begins on the second side of our array, and then it goes towards the higher side. So basically it is dividing the second part of our array. Okay, and then finally we call the merge function, which is going to merge our lower and the middle values. Okay, so here is my merge function, and it takes in the three integers which are actually the index numbers, and those are low, middle, and the high. For every array that we break down, it will actually take these three numbers. And essentially what we do in this case is, imagine you have two arrays, okay, and both of them are sorted arrays. So you are basically you start with the index number of the first array and the 0th index number of the second array, okay, and then you compare the elements in both the arrays. So so you can, let me draw this for you if I can. Okay, so let me draw this for you. This is going to be much more easier to understand. Let's say you have this array. This is, sorry for my drawing over there. So this is your first array. I'm really bad with this. Oh gosh. Okay, and this is my second array over here. Okay, this and this. All right, so I'm going to position my pointers over here and here. So this is essentially my merge function. And what I'm trying to do in this case is I'm going to compare these values. So let's say we have 1 and we have a 2 over here, okay? And I have this third array in which I'm going to copy these values, right? Let's say this is my third array. So I'll compare the first value with the second value, and if this one is lesser, in this case we have the 0th value less than the 0th value in the second array, which is 1, so I will put 1 over here. Now let's say we had a 3 in this case, and here we have a 4. Okay, now my pointer is going to move from here to here. Alright, so I'm going to take this off. Okay, I'm really bad with this drawing over here. Okay, I'm just going to continue, and there you go. Right, so now my index moves from 0 to 1, and this remains at the same position. Now I again do a comparison between these two values over here, and whichever is less is going to be added to this position over here. Okay, so let's say I will have 2 over here, and now my pointer is going to move to this position. Okay, so I increment the second index over here, and then again my battery is low. Let me quickly charge this. Yeah, so my pointer moves on the second position, and similarly we will fill up all these values over here. So now it will do a comparison between 3 and 4. 3 is lesser than 4, so I have 3 over here, and then my position moves over here. Okay, and let's say I had something else. So basically it is going to get filled up like this, okay, and you will have these values in the increasing order. So this is what merge essentially does. I hope that is clear. So I called merge on my array, and this is the while loop that you can actually see. So my current position is going to be assigned by the lower side. My x value, which is the middle value, is going to be assigned by the higher side. So here's the thing, you can actually imagine this as the complete array at this point. So let me go back to my drawing. So you can imagine this whole thing is just one array, okay, and my current position is this position, alright, and my mid plus 1 position is actually this position. So this is my mid plus 1, alright, and this is my mid value. Okay, so you can imagine this this whole thing as one single array itself, where we have created imaginary boundaries over here, okay, but it's actually a single array. So it takes this value and a pointer to this index over here, and the counter is assigned to low, so I'm setting the counter to this value, okay, alright, and then my while loop, in this while loop I'm actually checking if the current is less than or equal to mid and x is less than or equal to high. Okay, so what that means is my current is not going to go beyond this position, and my mid value, which is starting at mid plus 1, it is not going to go beyond this position. Alright, so that's what this first condition checks, and both of the conditions have to be true in order for this to work. Alright, and then we check if the array current position is less than or equal to array x. Okay, so this is what we are checking, if this value 1 is less than or equal to this value 2. Now if in this case, since that is true, what we do is we have the third array, or so essentially it's the temporary array that we have, and the counter, which is set to 0 at this point, because you can see low is set to 0. Okay, so my temporary 0 variable is set to the current position, array current position. Okay, so my array current position is 0 again. So since in this case our condition is true, so my temporary, this is my temporary array, and I'm actually copying this into this location over here. Alright, so that's my first, and then I increase the current position, so I'm pointing to the second position in the first array. Alright, and as it goes again, checks for this condition, we get inside this loop again. Alright, and now let's say we hit now it's the second condition, right? So is array current position is less than or equal to array, so my current position is going to be pointing to this second location over here, and my array x is going to be pointing to this position over here. So now 3 is greater than 2, right? So in that case I'm going to get into my else condition, and again my counter, I'm actually going to so I missed an important detail over here. My counter is going to be incremented all the time in every iteration. So here you can see now that it's actually on the second position, which is this position now. Okay, and we are assigning the array x, which is this value over here, to this position. Okay, so my 2 goes into the second position. So this is how this while loop continues. Okay, I hope it's making more sense at this point. So it continues in this way, and keeps on, you know, populating this entire temporary array over here. Okay, now once we get done with this loop over here, we check if the current position is greater than mid. And what this means is my current position, let's say, you know, this is the end of the array, so at the end, if my first site is exhausted, in that case, you know, my current position is going to point beyond this location, so it is going to be greater than mid, right? So we are checking if it is going to be greater than mid. Okay, that means, you know, it is pointing, it's gone, you know, past it's somewhere over here, or essentially it is, you know, pointing to this value over here. Okay, so if that is the case, that means, you know, my first array has been exhausted. All of, you know, these values are there in the temporary list at this point. Okay, so in that case, what I do is I take, you know, my low and then up to counter -1, which is, you know, where my counter has stopped at this particular point. I'm going to copy all my values. So in the array I, which is my original array, which I have defined in the class up there. So let me go back to the class. This is the one that we are talking about over here. So I'm copying all the values back from temp into I. Okay, so I'm going to assign everything back into my array. So essentially I'm making, you know, I'm taking this value, putting it over here, then this value, putting it over here, this value, and putting it over here. Okay, and this value, so my entire array is going to be copied into my original array over here. Okay, now if that is not the case, right, so which means that, you know, my first array, say for example my pointer moved till this particular location, and my second array was exhausted, so that means, you know, I'm at the end of, you know, this array, so I'm beyond, you know, this particular array. Okay, so I hope it is not getting too complicated, but so here is where I am at this point, and in the second array I'm already past, you know, the last element of the array, so which means I have a couple of elements left over here. Let's say, you know, I'm here and I have one more element left, which I need to, you know, make a part of, you know, this the original array. Okay, so essentially what has happened in this case is this value is bigger than all of, you know, the other values, because all of my elements have, you know, already got sorted. Okay, so these two values have to go at the end of, you know, my temporary array. So what I do in that case is I am looking at the current position, which is, you know, this position over here. Okay, and then I'm checking if it is less than or equal to mid. So it is, in our case, it is not equal to mid over here. Okay, because we are over here. So since we are less than mid at this point, I'm going to take array and then, you know, take the counter position. Okay, and take the kth value. So for example, imagine, you know, my k is over here right now, so it is 0, 1 and 2. So it is 2 plus counter, which will be at the end of, you know, this, and minus the current position, right? So the current position is again 2. So at the end of, you know, my counter, so for example, I have written from 0 to say 7 over here. So I'm going to start over here at the end. This is my 8th position and my 9th position. So I'm going to start at the 8th position. I'm going to write my value in this location, okay, which is what I'm doing over here. And so I'm copying the value which was located in this location into the 8th location, okay, and then I'm going to increment my kth value. So when I increment, this formula is actually going to yield me this location over here, which is the 9th position. Alright, and then I'm going to assign the array value to that location. So my array value goes in over here. Okay, now once that is done, once I have copied these two values to the end of my array, I'm actually going to copy everything from temp, which is this, all of these values into my array. Okay, so again, notice over here, this is my same array in which I'm actually copying the kth elements. So essentially what I'm doing is this specific array, which was one single array, as I told you earlier, I'm actually copying this value at the end of this whole array. Okay, so that's where I'm putting all these values. So you can see this is going to go over here, and this value goes at the end somewhere over here. Okay, now I know it is not looking really good, but I hope you can bear with me. So once I copy these values, I'm going to copy all of these values from my temporary array, which is 1, 2, 3, back into my actual array. Okay, so that's what I do over here. So that's exactly what this function does. And once this merge function is executed, all my elements are sorted. Okay, now essentially we are doing this recursively, so we are breaking it down into single elements. So this is what the sort array, this whole function does. It actually breaks it down, and then we run this merge on it, on the last elements, and kind of so it's a tree, and the depth of this tree is log n. Okay, so in terms of time complexity, since we are using the divide and conquer approach in this, it's breaking the array down by n by 2 in every iteration, as you see over here, by calling it recursively. So it will actually go to a depth of log n. Okay, so the total depth of my tree is going to be log n, and since we have this one while loop which is going to run n number of times, and then we have these two for loops over here, so in total this is going to give me n inputs. So the size of this thing is going to be n, so it is going to be the time complexity is going to be n log n for this sorter. Again, it's in order to understand the mathematical details, you can actually get in depth of merge sort, but just by looking at this, you can imagine that it is, since this is going to be a tree structure, it is going to break down and going to run log n times, and this is going to run n times. So it is n log n. That is what the time complexity is for this. Okay, so let me show you how it looks like. This is how the recursive calls actually look like. This is from my professor's book. His name is Paul Berman, or Kenneth Berman actually. So he has written this. This is a really good book if someone actually wants to learn about advanced algorithms. And essentially you can see visually how this works. So as you see, we start with 0, 4 and 9 in this case. Okay, these are the indexed numbers which are low, mid and high. And as we go down on the left hand side, we take the first two values, which is 0 and 4, and take the mid value of it. So 0 plus 4 by 2, that is going to give me 2. So I have 0 as the low, mid as 2 and high as 4. Okay, and then I again call my left function recursively. So I have 0 plus 2. Okay, so I will take these two values over here, and then that will be divided by 2 again. So I will get 0 as my lower value, 1 as my middle value, and 2 as my higher value. Okay, and then I again do the same thing with the first two values over here. So this is going to give me 0. Alright, and if I do try to divide it further, this is what I get, and this is my stopping condition. It hits the stopping condition. So let me show you the stopping condition quickly. So here you can see this is my stopping condition if low is less than high, right? So in this case 0 is not less than 0, so I go back and then I start going towards the right of it, and again 1 and 1, that is what we have. So I go back again from here, okay, and then over here. So essentially here I'm for the right side of the branch, I'm actually taking the right two values. So my lower value is 1 and my middle value is 1 plus 2 by 2, okay, and then my right value is 2. Okay, and then I go back again from here and repeat the same thing. So I have 2 and 4, and then I go towards the right hand side, and then I get all these coordinates again, and it kind of continues like this. And then for the same thing, then I have I go on the right hand side of this specific tree and kind of repeat the same procedure, so you get a good idea about this, right? Again, so once I run these two functions over here, my array is going to be sorted in n log n time. So this is how my print array function looks like, and it essentially is an iterator, and it takes the array begin, and if it is not equal to array n, we keep on printing the values. Okay, and here is an array that I've taken, which is an integer array, and it has all these values over here. Okay, and then I am creating an object of MergeSort, which is my class. So I'm instantiating an object and initializing it with integer array and passing it by a reference to my function. And then I call the sort array v1 function that I showed you earlier. Let me go back again. So this is my sort array v1 function, and then I call the print array on it. Okay, so it prints out all these values in my array in a sorted order. So let me show you how this runs quickly. Here is my compiled executable. So I'm going to call MergeSort.exe, and you can see it has 1, 5, 8, 19, 40, 3, 6, 22. Okay, and I'm going to press enter. And here is my sorted array. So you have 1, 3, 5, 6, 8, 19, 20, 40, 54. Alright, so that's my MergeSort implementation. I hope that is going to help you, or maybe you can write up your own MergeSort implementation. I hope this was helpful, and I'll make more of such videos to help you guys with writing these different types of codes. Alright, thank you so much, and have a good one. Bye bye.